You're scrolling through a sea of microscopes, wondering which one will actually sit on your desk, work every day, and feel worth the cash instead of just being a fancy gadget with a long list of specs. You've probably felt that twinge of doubt. What if you spend money on a unit that looks great on paper but ends up being a headache when you need it for a school project, a hobby, or a small lab? That hesitation is real, and it's why I'm spending a few minutes breaking down the OMAX MD827S30 PhD 3MP digital integrated microscope so you can see whether it fits into your daily routine or if you should keep looking. Link is in the description if you want to check the product details on Amazon. First, let's talk about the kind of microscope most people actually need when they're not a university research lab. Most hobbyists, teachers, and DI enthusiasts want something that's easy to set up, gives a clear image without endless tweaking, and doesn't require a separate camera rig or a stack of accessories. They also want reliable illumination because a dark field makes any specimen look like a mystery. The OMAX MD827S30 PhD hits those basics hidden. It's marketed as an economical system, and the price point reflects that intent. No hidden subscription fees, no need to buy an extra webcam, and the whole package arrives ready to plug into a laptop or desktop. The first thing I noticed when unpacking the unit is how straightforward the assembly is. The stand, the arm, and the integrated 3-megapixel camera snap together without any special tools. For a teacher prepping a biology class, that means you can have the microscope on the lab table in under 5 minutes and start showing cell samples to a whole class. The camera sits right above the optics, so you're not juggling a separate lens or trying to align a USB cam on a trinocular head. That integration is a practical time saver, especially if you're moving between different specimens throughout the day. Illumination is where many entry-level microscopes stumble, but the MD827S30 PhD includes a built-in LED ring that provides even, adjustable lighting. In my own testing looking at onion skin slides, a piece of printed circuit board, and even a small gear from a model airplane, the light stayed consistent across the field of view. There was no need to fiddle with a separate lamp or worry about flicker when you adjust the zoom. For anyone who's tried a cheap microscope that left you squinting at a dim image, this is a noticeable upgrade. The magnification claim of up to 2000 can be a bit misleading if you're not familiar with how digital microscopes work. The optical zoom tops out around 200, and the rest comes from digital scaling. In practical terms, you'll get crisp detail for most educational samples and hobby projects at 200 to 400, but if you push beyond that, the image starts to look pixelated. Nothing surprising for a 3-megapixel sensor. If you need to examine fine solder joints on a PCB or the texture of a fabric weave at very high magnification, you'll hit the limits fairly quickly. That's a trade-off you need to consider. The unit gives you a lot of zoom for the price, but the digital zoom isn't a substitute for a high-end optical system. Software-wise, OMAX bundles a simple capture program that lets you snap photos, record short videos, and annotate images. The interface is not as polished as some premium offerings, but it's intuitive enough that a middle school teacher can launch it, click a button, and capture an image to paste into a PowerPoint slide. The ability to export directly to JPEG or MP4 is useful for teachers who need to share results with students or for hobbyists who want to post their finds to a forum. One downside is that the software runs best on Windows. Mac users will need a workaround or third-party capture tool, which can add a layer of inconvenience. Now, who should actually consider buying this microscope? If you're a high school teacher looking for a classroom-friendly tool that can demonstrate cell structures, plant tissues, or basic material inspection without breaking the budget, this is a solid match. The same goes for a hobbyist who enjoys looking at insects, minerals, or small mechanical parts and wants to share images online. Small business owners who need a quick visual inspection of product components, think a jewelry maker checking setting integrity, or a hobby electronics shop examining solder joints will find the integrated camera and illumination handy for daily quality checks. On the flip side, if you're a professional researcher who needs sub-micron resolution, a microscope that can be calibrated for precise measurements, or a system that integrates with advanced imaging software, you'll likely be disappointed. The plastic construction, while adequate for light use, can feel a bit flimsy when you're moving the stage frequently or applying a heavier specimen. The working distance is also modest. Thicker samples might not sit comfortably under the objective without needing a custom slide holder, something that higher-end models include out of the box. Another practical consideration is the long-term durability of the LED light source. LED life.